Chapter 3. Displaying and describing categorical data. The 3 rules of data analysis are: number 1, make a picture. A display of your data will reveal things you may not see just in a table of numbers. The second rule is also make a picture. A well-designed display will show important features or patterns in the data, and it's the patterns and unusual features that we're going to be more interested in, and some type of display helps us see that. The third rule is make a picture. So make a picture, make a picture, make a picture. Again, a display or graph helps tell others about your data a lot better than just a list of numbers. Frequency tables. For categorical data, we count the number of cases corresponding to each category. A frequency table is how these counts are organized. So for example, we have the variable of eye color and then the count. So this tells us we have 13 brown eyes, 11 blue eyes, 8 green eyes, and 3 hazel eyes. Proportions are often more useful than counts. Proportions are generally shown as percentages, but can also be shown as fractions. So a relative frequency table displays the percentages of the values in each category. So again, we have our variable of eye color, but then over here, instead of counts, we have the percentages that they make up. An important thing to note is that the words relative frequency indicate you are using a percentage. So if you have a relative frequency bar graph, you're using percentages instead of counts. The area principle. Once you have a frequency table, you can make a picture of the data. It is important that whatever display you use follows the area principle, which states that the area occupied by a part of the graph should correspond to the magnitude of the value it represents. If you look at the picture on the right, this shows an example of a violation of the area principle. So this graph represents the number of passengers on the Titanic and what type of ticket they had. The numbers on the bottom should be 0, 300, 600, and 900. So if we look, the crew makes up about 900 passengers. Those with second-class tickets make up about 300. So the crew boat should be approximately 3 times as big as the second-class boat. However, it's not quite that. The crew boat appears to be much more than 3 times as big as the second-class boat. And our eye tends to see the area over the length or the height, so you have to make sure the area corresponds. Bar graphs. A bar graph displays the counts for each category for comparison. When you make a bar graph, you must follow the area principle. Also, the bars on a bar graph should never touch, and you should always have labeled axes and a consistent scale. The width of each bar must be the same so that just the height or the length will show the count. That, again, helps make sure that you are following the area principle. A relative frequency bar graph uses percentages instead of counts. Pie charts. A pie chart is a circle sliced into pieces. Each piece has to be proportional to the fraction it represents. Pie charts give a quick impression of how a whole group is divided and are easy to use when you're already using fractions or percentages. A pie chart should have a key associated with it, so that way you can tell what each piece of the pie represents. Contingency tables. We can look at 2 categorical variables in a contingency table. Often looking at 2 variables is more interesting than looking at just one. And it shows how one variable is distributed contingent or based on the value of the other variable. So an example would be right here. We still have our eye color, but now we also have gender. So when we can read this as saying that we have 8 males that have brown eyes, or 2 males with green eyes, or 6 females with blue eyes. And then we can see in the bottom and far right columns and rows, those have the totals. When shown like this, the frequency distribution of one variable is called its marginal distribution. So this tells me that we have 13 people with brown eyes, 11 with blue, 8 with green, 3 with hazel, or that we have 16 males and 19 females, and a total of 35 people surveyed total. So let's practice using a contingency table. So I want to know what percent of the class are girls with blue eyes. Okay, so I'm going to grab a pen real quick. So we're looking at the class, so that's going to be out of everybody. So it's going to be out of 35. Not the best with the pen, sorry. So it's going to be out of that. But then we're looking at girls with blue eyes. So we go to female blue, and there are 6. So 6 with blue eyes. So then we want to know the percent of females with that are brown-eyed. So now we're only looking at females. So we want to know what percent of females. So now our total is only out of 19. And they have to be brown-eyed. And we're only looking at the females, so it's going to be 5. So 5 out of 19. Okay, so then we want to know what percent of brown-eyed students are female. Okay, so now we're only looking at brown-eyed students. So that would be this column right here. So the total is now 13. So now we are out of 13. And female, there are 5 female with brown eyes, so it would be 5 out of 13. Okay, so that is roughly how we can go about using the contingency table. We'll practice more with contingency tables tomorrow in class. I will see you then. Thank you.